You are welcome. Our discussion is on chain rule on trig functions. So you're looking at how to perform chain rule on differential equations or functions that have trig in them. So we're looking at how the trig functions are differentiated, or if they have functions that we have to apply product rule or quotient rule to, then we know how to go about performing the differential or the derivative of such functions. So we are looking at some of the trig functions and how their differential is determined. So first we look at sine. So for a function of sine x, its differential is cos x. A function of sine x, its differential is cos x. A function of cos x, its differential is minus sine x. Function of cos x, its differential is minus sine x. Then the function of tan x, its differential is sec squared x. Its differential is sec squared x. And for cosec x, its differential is minus cosec x cot x. Minus cosec x cot x. Then a function of sec x, its differential is sec x tan x. Sec x tan x. Then a function of cot x, its differential is cosec squared x minus cosec square x. Its differential is minus cosec square x. So these functions with trig in them, then how they are differentiated. So we take note of this because they will be applied in problems that we're meeting in our differentials as we move along. But we should take note of this. Tan x is sine x over cos x. Tan x is sine x over cos x. And cot is 1 over tan. So therefore, cot x is cos over sine. Cot x is cos over sine. So we should take note of this because it will be applied in frequent trig functions that we're meeting in the differential. Then also, sec x equals 1 over cos x. Sec x equals 1 over cos x. Then cosec x equals 1 over sine x. Cosec x equals 1 over sine x. So now let's look at some examples that has trig functions and how they will be differentiated. So firstly, we are applying the chain rule on each equation, or we are applying the chain rule on each function in this trig function. So the first question is, find the derivative of h of x equals cos of 5x to the power 5. Cos of 5x to the power 5. So let's look at how chain rule will be applied to this function having trig function in it. So with the solution, we state out the chain rule, which is dy dx equals dy du dot du dx. Dy dx equals dy du dot du dx. Now, we know that f of x is equal to y. F of x is equal to y. But in the question here, it is h of x, so it implies the same thing. So h of x is equal to y. Now, our y becomes cos u. Our y becomes cos u, meaning 5x to the power 5 is now our u. So 5x to the power 5 is now our u. So we have to find dy du. Since our y is equal to cos u, we have to find dy du. So dy du gives us minus sine u. We know that differentiating cos gives us minus of sine. So our differential dy du becomes minus sine u. Now, we know earlier u is equal to 5x to the power 5. So therefore, we differentiate u in terms of x. So our du dx therefore becomes 5 into bracket 5x to the power 5 minus 1. So first, we separate the coefficient of x. Then we bring the exponent, which is 5. Then it comes to multiply x. Then we subtract 1 from the exponent. So that is how the differential is done. So therefore, we are having 5 into bracket 5x to the power 5 minus 1. So we multiply the 5, which we separated, which was the coefficient initially, by the 5, which we brought from the exponent. Then we are having 25. Then we subtract 1 from the exponent, giving us 4. So du dx here is now 25x to the power 4. So now we have our dy du, then we have our du dx. So therefore, let's put them together, then we have the complete differential of the problem. So dy dx is equal to dy du times du dx. So we have to put them together. Our dy du is minus sine u, as we solved earlier. Then our du dx is equal to 25x to the power 4. So we've brought them together. But there's an odd in this. The derivative is in terms of x, but we are seeing u here. So we have to do the necessary substitutions. You have to bring back the u that we replaced, which was u equals 5x to the power 5. So we are supposed to replace the u here. So we're having minus sine of 5x to the power 5 times 25x to the power 4. So after we simplify everything, we're having dy dx to be equal to minus 25x to the power 4 times sine of 5x to the power 5. So this is the differential applying chain rule to a function having trig in it. So this is the final answer of the derivative. So now let's look at another question. Find the derivative of k of x, which equals sec into bracket 4x to the power 6 plus 3x. 4x to the power 6 plus 3x. So let's look at the solution together. Firstly, we state out the equation of the chain rule, which is dy dx equals dy du over du dx. So this is the equation of the chain rule. For that, we denote our function k of x by y. So y will be equal to sec u. Y will be equal to sec u, meaning we replace the terms in the bracket with u. Meaning u is equal to 4x to the power 6 plus 3x. 4x to the power 6 plus 3x. So this is our u. Now, we therefore find the differential of dy du. So we find the derivative of y with respect to u. Since we replace the terms in the bracket with u, our differential changes to dy du. So we know that find the derivative of sec will give us sec times tan. So therefore, we're having dy du to be equal to sec u times tan u. So this is our differential. Now we are supposed to find the derivative of u with respect to x. Supposed to find the derivative of u with respect to x. So doing that, first term in the expression, bring out the 4, which is the coefficient. Then we bring the 6 to multiply the x. Then subtract 1 from it. So the 4 becomes the coefficient, we separate it. Then the exponent, which is 6, becomes the coefficient as well, multiplying the x. Then we subtract 1 from 6. Then the second term, we separate the 3. It has an exponent of 1 here. So we bring it in front, then we subtract 1 from it. So this derivative will leave us with 24, which is from 4 times 6. So 4 times 6 give us the 24. Then 6 minus 1 will give us 5. Then 1 to the power 1 is 0. So x to the power 0 will give us 1. We know that any number or variable to the power 0 is 1. So we're having du dx to be 24x to the power 5 plus 3. So we now have specific components of the chain rule. So now let's put them together. We state the equation of chain rule. We are putting them together. We put dy du, then we input du dx. So after the substitution, we are getting sec u tan u times into brackets 24x to the power 5 plus 3. So this is the function you're getting after the substitution. So we are supposed to substitute back the u we replaced. Into the equation. So we are having sec into brackets 4x to the power 6 plus 3x. Then tan into brackets 4x to the power 6 plus 3x, multiplying 24x to the power 5 plus 3. 24x to the power 5 plus 3. So this is the differential. So after simplifying everything, we leave it the same because we can't break it down. So we're having dy dx to be equal to 24x to the power 5 plus 3, multiplying sec of 4x to the power 6 plus 3x times tan into brackets 4x to the power 6 plus 3x. So this is the approach at which we use to solve functions having trig, how we apply the chain rule on such functions.